Welcome back to a new series. Today we will talk about onboard Arduino. Many people ask me how to prototype their projects. Is there any way to just use a programmable IC? So today I am going to show you how to program ATmega 328P microcontroller IC and use that IC into your projects instead of using whole bulky Arduino. So let's begin. Here is a list of components that you can see. We need a PC with an Arduino IDE installed, 328P Arduino IC, ATmega 328P IC mainly known as, an Arduino, some sort of jumper wires and a breadboard to place all the components together, 7805 voltage regulator IC, an LED, 22 picofarad capacitors and 10 microfarad capacitors. And we also require a 10 kilo ohm resistor. So here you can see the diagram or pin mapping of ATmega 328P IC. This diagram shows what are the Arduino functions that are performed by this IC. This IC is the brain of Arduino Rev V3 version. So here you can see that we have placed ATmega 328P IC, our reset switch, a resistor, 22 picofarad ceramic capacitor, 16 MHz oscillator and an LED. So the first pin of the IC is defined by this notch. So here the first pin is connected to reset. It's going to reset your whole system. After that the 7th pin of Arduino is connected to VCC, 8th pin is connected to ground, 9th and 10th pin are connected to 16 MHz oscillator, and here are 22 picofarad capacitors. They are non-electrolytic capacitors. There is no issue of poles, negative or positive. You can place any way you want. So these are placed. This is a whole circuit diagram. LED is connected here, digital pin number 13, which is pin number 19 of IC. Pin number 20 is again connected to VCC and pin number 22 is again connected to ground. So the main question arises how I make these connections. So let's move to our previous slide to see. So here you can see that pin number 1 is defined as reset pin. So we have connected it with our switch. Pin number 7 is defined as VCC. So we have connected it to 5 volt or 3.3 volt as by your requirements. Pin number 8 is connected to ground. After that we have connected pin number 19, that is defined as digital pin 13 of Arduino. So we have connected it to LED. Pin number 20 is connected again to 5.5 or 3 volts according to your requirements. Pin number 22 is again connected to ground. Pin number 9 and 10. Here you can see it's written TOSC1 and TOSC2. So these both pins are reserved for connecting the oscillator. So we have connected oscillator to pin number 9 and pin number 10. So here our circuit diagram is complete. Now we are going to make a power supply for this circuit. So here you can see that we have designed a power supply. It's a 3.3 volt power supply. I have placed 7805, which is a 5 volt regulator IC, and LD1117. That's a 3.3 fixed voltage regulator IC. I'm powering up my circuit with 9 volt battery. You can use a 12 volt DC power supply. So I have placed 2 capacitors here to remove the AC component. As for further use I am going to use the 12 volt DC supply. So it's pretty simple. I am explaining this IC. This IC consists of 3 pins. First pin is for input, second pin is ground for common ground for input as well as output, and the third pin that's going to give you 3.3 constant voltages. So now the basic question is that how we are going to program this circuit, how we are going to program this IC that is stick to our breadboard. So here is a way we are going to program our stick breadboard IC. Yes, we need an Arduino. As I have already told you before, I have removed the IC. The IC I am using here is removed from my Arduino. So here you can see that it's a simple configuration. You can just pause the video and do have a look. I am also explaining it. 5 volt is connected to 5 volt, ground is connected to ground, reset pin is connected to reset, and these two pins, one pin is RX, other one is TX. RX pin is connected to pin number 2 and TX pin is connected to pin number 3. So how we have connected these pins? Let's move back. So pin number 2 RX pin, pin number 3 TX pin as defined by our data sheet. Without wasting much time, let's program our Arduino. So here you can see that we have created our onboard Arduino. So how it look like. So now I am going to upload a code on it. Here you can see that we have already opened a blink sketch here, and now I am going to first of all check that my Arduino is connected or not. Arduino UNO, port number 5, Arduino as ISP, done, and I'm going to hit the upload button. Compiling sketch. Now it says done uploading. So here you can see that blink sketch has been successfully uploaded to your onboard Arduino. You can see that I have removed the IC from the Arduino and it is placed on breadboard, and our prototype is working fine. Thanks for watching. Please don't forget to subscribe.